Good morning. Today's lesson is 5.09 unions and intersections. The aim is how could we compute the probabilities of a union or an intersection. So yesterday or Monday's lesson was really about identifying and understanding the wording, as well as understanding potentially how to diagram it. This lesson is really about how do you find the values behind them. So here's your do now. You got two questions. What is the maximum amount of people that could have bought a clock or a watering can? And then suppose 10 people bought a clock and a watering can. How would that change your response to question 1? Alright, so when you're done, come back and check this out. So let's review. What is the maximum number of people that could have bought a clock or a watering can? So I am using a bit of a Venn diagram. I find it very useful to organize data, and when I'm trying to explain it to you guys, it does make it a little easier because there's a visual. So I got red is the clock, green is watering cans. So based on the diagram, right, 53 people bought clocks, 47 of them bought watering cans. So what that would mean is one or the other, right? The or statement, you could have either bought a clock or bought a watering can and still been counted, so it's just 47 plus 53, which equals 100. Now, what happens if we have 10 people that bought both? Well, there's 10 in the middle, right? What I want you to realize, right, is that 10 is part of this circle, so it's part of this 47, that 10 is also part of this circle, part of that 53. So what that really means is whether or not you realize that 10, those 10 people are being counted twice, right? They're counted in this 47, they're counted in this 53. So when we find the totals, right, it's really 53 plus 47 minus 10, because we need to take out those 10 people that were counted twice. So let's review, right? Unions and intersections. If you're talking about a union, right, that's the or statement with the U. Everything's covered, right? Because this circle is A, this circle's B, so A or B means it could be A, it could be B, it could be both. The intersection means it has to be both, right? And the way where is it both and only both? Right in the middle where they overlap. So now let's talk probability rules, right? So when we're finding a union, when we're here, we do not count the intersection, which is what we did in the do now. So we take the rule, which is the union of A and B is the probability of A plus the probability of B minus the probability of A and B. And I'm going to write that out for you. Probability of A plus probability of B minus the probability of A, and B. Again, because those doubles, right, those ends are counted twice, so we need to make sure we remove that. Second rule is when finding an intersection, we do not count the union. So probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. So really, this same rule just reversed. So you got two problems that I want you to try for guided practice. When you're done, come back and check your answers. Alright, let's check. So, student goes to the library. The probability that she checks out a work of fiction is 0.4. So I'll call the green fiction. A work of nonfiction is 0.3. And both fiction and nonfiction is 0.2. What is the probability that the student checks out a work of fiction or nonfiction? So we're finding the or, so we need to take either, add them, and then subtract both. So 0.4 plus 0.3 minus 0.2 is 0.5. So this student has a 50% chance of checking out one or the other. A survey of college students found that 56% of them live in a campus resident hall, 62% of them in a campus meal program, and 86 do at least one. What's the probability that that a randomly selected student lives and eats on campus? So this is a little different, right? Because what do we have? We have the probability of A, probability of B, and then the probability of A or B, which is that 86%. So to find A and B, we do probability of living on campus plus the probability of eating on campus minus the probability of eating or living on campus. So 56 plus 62 minus the 86 leaves us with 32. So there's a 32% chance that they both live and eat on campus. So you are going to do the same thing for the independent practice using this scenario here. So, and then come back tomorrow, your responses will be there. Have a great day, guys. Good luck on your AP exams.